Great. Let's kick off. So, Murray, could you send me so I can share? There we go. Thank you. Um, for most companies, we are at the point now where LLMs are plenty smart enough for most use cases. There are only a few use cases left, I think, at least in the things that we think about, where the intelligence of the LLM is the main bottleneck. What we're finding over and over again is that what's really the bottleneck from more LLM usage is their ability to access real data. Things are changing really quickly. A few years ago, before LLMs, everything was point and click SaaS. Things looked like Jira or Asana or Salesforce, which were essentially just databases with like nice form-based UIs on top. And the way we'd interact with things was, like I said, point and click. Like if you wanted to edit a task in Jira, you would have to go into Jira, find the task, click the fields that you want to change and edit those fields. It was quite painful. Nowadays, my view, and I think it's becoming very obvious, is that we will interact with everything, all of our applications, our Jira, our Slack, our Gmail, directly through LLMs, through agents, through chat. This might seem kind of extreme, but if I told you, 5 years ago that you wouldn't be using Google anymore, or you'd be using it a lot less, you'd probably think I was insane. But now it's pretty obvious that most people use Google second. Or if they do use Google, they're going to be using the AI mode much more than they would use the traditional search and click. And so things are changing. And one thing for agent builders is when people build LLMs, the first thing we're told, like if you go Google, like build an LLM application or an agentic application, almost the first thing you see is RAG. And so we've kind of have this view as an industry that the way to solve all problems is with RAG. The problem with RAG is for many use cases, it sucks. In fact, I would argue that most LLM features in production today are just glorified summarizers. So for example, if I was at DoorDash and I was building RAG, the first thing I would need to do is find some text to be able to like index. And so typically what people do is they use help centers. So then what happens is if someone asks, why is my DoorDash taking forever? I've been waiting for an hour. The response you're going to get is going to look something like, here are common reasons for delays. It's not going to be anything about your specific order. The reason for that is with RAG, you typically index a corpus of text, which is public. So all of the paragraphs are allowed to be used by every person. And that means that all the answers are generic. And again, what that results in is essentially a summarizer of your docs. Just to maybe dive into how DAG work or how RAG works more specifically. This is how we're taught it. So we start with documents. We use an embedding model to index them, which just makes them really searchable. So I can look for paragraphs like this paragraph. Then when the user asks a question, such as, why is my DoorDash taking forever? What we do is look for paragraphs in the documents. In this case, it's almost always going to be your docs or help center that are relevant to a late order. And so that's what you're going to get. This is fine for most use cases. LLMs, were new. And so when we started, just even having a response to any question, not having to dig through docs and help centers was dramatically better than what we had before. But as always happens, our bar as consumers goes up very quickly. So it used to be the case that just answering simple queries, like in the bottom left here, was enough. That was really powerful. You can ask questions, any question, and receive an answer if there's any relevant, text about that information. that was kind of the RAG wave. A lot of that hype has kind of died. There's still a lot there, and I think it's actually overly died. It's kind of like the trough of despair. It will pick back up. Um, but what's changing now is as we're realizing how powerful LLMs are, we are beginning to build up the stack to tasks and workflows and even autonomous agents. The thing about those use cases is RAG actually becomes a lot less powerful when you're dealing with agents. The, the thing you actually need is access to real data, which has always been tough. So that, for example, when someone asks, why is my DoorDash order taking forever? You can go and retrieve the order information, the user information. You can maybe perform tasks like giving a refund or doing something similar. That's what's required to move up this chain. And the thing that finally happened to unlock this is MCP. So for those of you who've not heard of MCP or maybe have heard of it but don't really know what it is, MCP stands for Model Context Protocol. You can think of it as it enables servers like a Gmail server or an API server to give an API that any agent can connect to. So if I'm Slack and I want people to use ChatGPT to interact with me, I just give them an MCP API. Why this is really powerful is before, the agents themselves would have to be integrated to the Slack API. Now, me as a remote service, I can actually give you an API to connect to remotely and interact with things. I can do things like authorization and other things as well, so that you can interact with just your emails or just your calendar. Um, and what this is going to unlock is the ability for us to use MCP to actually start to retrieve real enterprise data. When people typically think about MCP, they think of, oh, I can connect to Slack, I can connect to Gmail, I can connect to Jira, which is very powerful. But what a lot of people don't know is that the most common use case for MCP in the enterprise is the ability to access their enterprise data, proprietary data, to do things like what we call agentic enrichment. So that when someone says, why is my DoorDash taking forever? Rather than giving a generic response, it's going to go and it knows that it has access to check the order database and all these other things to get the data and information that it needs to give a proper response to that problem. So this is agentic enrichment. And the thing about MCP, though, is it's a bit low level to do this. What MCP enables is that you can define tools and resources. So you write all these functions for tools and resources, and you kind of have to build your stuff from scratch. What we found is that the best way to make this work, because a lot of people will go and build MCP servers and they won't actually work. This is really common when people take their REST APIs and they try to wrap them with MCP, and they find that the model actually does not call the right things at the right time. The way that we've designed EnrichMCP kind of looks like an ORM. If you've ever used an ORM, it's going to look very similar. The core, the most critical piece, is what we call the semantic engine. What you do there is you define your business model. So if you're an e-commerce store, you would define users and orders and items and their attributes and their relationships. And you would define the semantic graph of your business. You would link that semantic graph to serving. We have some automated ways to do that. For example, if you use SQL Alchemy, we can turn your SQL Alchemy model into an MCP server, or you can do it manually. I'll show the different examples. On top of all of this, you can build in governance, access control, etc. All the things that you would need to be able to do this securely. But you can tie it to the semantic graph again. So far I've been being very theoretical. I've talked a lot about what MCP is, how Enrich solves it, but I want to jump into code and show you in more detail. So first examples I want to show you is the simplest example here. So here what I have is a SQL Alchemy model. For those who don't know, SQL Alchemy is a very, very common ORM for Postgres. And an ORM, also, if you don't know, is a way to map your databases like Postgres into objects in your language like Python. So rather than writing SQL and then taking the SQL, converting it into my objects, I can actually map my objects directly to tables. And then I can use the APIs to essentially convert into SQL. So it's very common. Now, what we do is we actually enable you to see and look at all of these columns. Um, or rather, what we do is like you would take this. This is just SQL Alchemy. This has nothing to do with Enrich. You add this Enrich mixin. You include SQL Alchemy models to your EnrichMCP server. And you run. And now your agent can connect to this database or this server, and it understands that your database has users and orders and all these fields that it can connect to. Let's say you have a REST API and you have customers and orders again. So you would define your data model using enriched models. If you've ever used Pydantic, this is a Pydantic-based model. You would define your fields and you would define your relationships. So in this case, you would define orders as a relationship. So a customer can have a list of orders. You then write these resolvers and retrievers to get customers, get customer orders, etc. And again, after doing this, your model and agent will have access to all of this stuff. Now, that sounds theoretical. Let me show you how that actually looks like. So I'm going to open up Claude, and I'm going to connect it to an EnrichMCP server that I'm running. And then I'm going to share that screen as well. So here I have Claude. This is just base Claude. I've connected EnrichMCP shop. I'll show you this code. It looks very similar to what I showed you. But all these tools get generated from the data model. If I write, you are a customer support agent, look for transactions. So this is a new chat, so it has no information. The first thing it's going to do is explore data model. This is generated by the framework. What it does is it takes all of those classes you made and it explains it in common language for the model in a way that it understands. It will say here that there are users and products and orders. Here's how the data model works. Here's all the parameters. Here's all these things about them. So it's a lot of information, but it's all the information that the model needs to understand what's going on. It then starts going through that data model. It starts listing orders. It sets parameters. It's actually using pages too. So it does a page of 20. It starts getting users, listing things, walking through things. And it finally gives a response. So again, going to like the DoorDash example, or going to like a RAG example, if you say you are a customer support agent, look for fraud transactions, it won't work because it doesn't have access to the actual data. It just has access to some text and documents. So this is what enables that. The other thing that's interesting, which I'll show you, is I've actually connected two EnrichMCP servers. There's EnrichMCP shop, which was all the order information, and EnrichMemory, which actually gives you memory. So what it did, which is kind of cool, is it wrote a note to itself about some of the things that it learned. So it created a note, a memory note for itself later to be able to read based on what it learned today. And that memory would actually happen across transactions. But that's kind of the power of MCP, is that you're just giving these tools to the model and letting the model's intelligence interact with the tools. Rather than before, when you would build agents, what you would do is you would hard code the tools and into the agent itself. Now you build an agent, you make the agent smart, and then you attach it to the information that it needs to be able to get a job done. So it's like a plugin architecture. Cool. Was I not sharing my screen for that? No, I was. Okay. So last thing I'll show you all is maybe a deeper dive into that memory, the memory example. So the way the memory example works, actually, before the memory one, let's do the shop one again. So first, let's look at the orders in shop. What you do is you create this class user. You define this description. This description becomes a part of the user entity. So this PyDoc gets pushed down to the model. You define all these fields and their descriptions. Again, these descriptions get pushed down to the model as well. You can define complex relationships. Like a user has a list of orders. That description as well is documented. You're defining your data model. We turn this data model into something that the agent can use. Then we have some fake data. So I'll scroll through. And then you can start defining your resolvers. So this is saying from an order, here's how you can get the user attached to it. From a user, here's how to get their orders. You define also retrievers, which are like top-level routes. So you can say list users. This will list all the users. You can get user based on an ID. You can list products, list orders. There's a lot of things you can do. And what you're doing is you're defining this data model and you're defining these interactions and you're defining the governance. And then this becomes something, it's like that is enabled the agent to be smart. You can build a lot of really interesting things. Like you can build memory from scratch. So the way memory works is we just have create note, get note, and list notes. We define some fields of like what a note is made up of. We have a backend where we define what a memory note is, what the summary is of a memory, and then a memory store. So it looks like traditional engineering. The big difference is that the PyDocs, the descriptions, all those things are critical to make this work. If you get those wrong, like if you do this wrong, your model won't call the right tools and do the right thing. It's even more complicated if you work with MCP directly. With Enrich, because we have your data model, we make it work significantly better. And we've seen that time and time again with our users and customers. So that's all I have for you. If you have any questions, I'm happy to answer them. You can put them in Q&A and I'll give you an answer. Give it a few minutes. And then maybe while I'm doing that, Marie, you could talk through what happens next.
Sure. Thank you guys so much for taking the time to watch this webinar. After this, I'll send you guys a little follow-up email. It'll have the recording to this webinar. So if you wanted to look back at something or you came in a little late, you're welcome to take a look at that. We'll also send you links to our Slack community and our GitHub repo. The Slack community has a bunch of other people in the data and AI and ML space you can connect with. You can also reach out to us if you have any questions about our products. And yeah, the EnrichMCP is our latest and greatest product. So y'all should try it out.
Awesome. Well, thank you, everyone. Oh, there's a Q&A question. Great session. Yeah, thank you so much. I hope that was useful. EnrichMCP is open source. It's free. We don't even have a paid version of it yet. So go play around with it, see what you think, and let us know. Otherwise, have a good rest of your day. Thanks.